Connective tissue is the most abundant tissue type in the body. If you took away all of the other tissue types and just left connective tissue, you'd still look like you. We might be a little bit skinless, but you'd still have that main structure of your body. Connective tissue itself consists of an extracellular matrix that contains a fluid called ground substance, and it also contains a number of fibres, which include collagen fibres, elastic fibres, and reticular fibres. Connective tissue doesn't have very many cell types, it has very few, and they are widely spaced. But the cell types that it does contain include white blood cells such as phagocytes and lymphocytes. It contains white blood cells, and it also contains mast cells as well. So they're just a few of the cell types that it does contain. Connective tissue is highly vascular, so it has a really good blood supply to it. So what is it that connective tissue does? Well, it is the structural framework of our body. It is our bones, it's our skeleton, so it's holding us up, it's helping hold us upright. It's involved in the transport of fluids and dissolved solutes and nutrients throughout the body, so blood itself is a type of connective tissue. It's involved in protecting our organs, so if you think about the functions of our skeletal system, we have a rib cage that is protecting our heart, for example, and so it's protecting those important organs. It supports, surrounds and interconnects our other tissues. It makes sure that our organs are where they are meant to be. It's kind of anchoring organs in place. If we didn't have that connective tissue, gravity would take effect and we'd kind of just be a bit of a slump of a pile, might be the blob on the floor. It's also involved in storing energy. We store energy within the fat cells within our connective tissue, and it's also involved in the defense of the body because it does contain white blood cells such as the phagocytes and the lymphocytes that I mentioned in the previous slide. So there are 4 different classes of connective tissue. We have connective tissue proper, which is classified into dense and loose connective tissue. We have bone, that is a type of connective tissue, as is cartilage, and as I mentioned previously, blood as well. So there are 4 classes of connective tissue. Now, why are these all classed together? Well, they all arise from the same embryonic tissue called mesenchyme. So that's why they're all grouped and classed together as a type of connective tissue. So the image on the screen is showing you a number of examples of where we find connective tissue. So for example, the adipose tissue within our bones, or we might have blood. We do have blood vessels running through our bones. They're all types of connective tissue. So loose connective tissue gets its name because it has a very loose arrangement of fibres, and in having that, it also has a very large amount of ground substance. So the image on the screen, the adipose tissue, which you'll find in places like under your skin and surrounding your organs, hopefully not too much, you don't want too much there. It's involved in cushioning and protecting our organs and our vital areas of our body. And we also can store energy within our adipose tissue as well. So the adipose tissue is just one example of loose connective tissue. We're not going to go into any more detail on the loose connective tissue. It's just to make you aware of this different classification. We also have dense connective tissue in our body. So both of these, remember, are connective tissue proper. And in dense connective tissue, the fibres, and it's actually collagen fibres, are really closely packed together. So there's very little room for the ground substance, there's very little room for the fluid itself. In contrast to the other materials, it is poorly vascularized, so it doesn't have a very good blood supply. So an example of something of a dense connective tissue would be something like a tendon, which attaches muscles to bone. So bone itself is a type of connective tissue, and it's really abundant in collagen fibres. Now these collagen fibres, which I've mentioned a couple of times, they provide tensile strength to the body. So we need these fibres to provide that tensile strength. The 2 of the main cell types that we find within bones, they're not the only cell types, but 2 really prominent cell types are the osteoblasts and the osteocytes. So the osteoblasts are responsible for producing the matrix, that ground substance and the fibres, and the osteocytes are responsible for maintaining the extracellular matrix to make sure we've got that ground substance and the fibres all the time. So bone's involved in supporting, protecting and storing fat, as well as the production of blood cells. So if we need more red blood cells, we have hematopoietic stem cells for our blood in our bone, and we can produce more red blood cells. But we'll learn more about that later on. Bone itself is highly vascular, so it has a really good blood supply. And we'll look at the functions and what bone contains later on in the semester when we actually talk about bone itself. Cartilage is another type of connective tissue, and we find cartilage in a large number of locations in the body. You have it in your nose, you've got it in your ear, but we've also got it in our joints as well. So it's lining the bones of our joints and making sure that the bones aren't rubbing on each other. So it's reducing things like friction, it's involved in absorption, so things like shock absorption and stuff like that. So cartilage does contain the collagen fibres and elastic fibres, and the cells that produce the matrix, that extracellular matrix, the ground substance and the fibres, they're called chondroblasts. So if you have a look, the cells in bone and cartilage, both cell types end with blast, meaning that they produce the matrix. So cartilage, as I said before, is involved in absorption and compression as well in terms of like our joints, and it really does support our joints and different areas of our body as well. Cartilage, unlike bone, doesn't have a very good nerve supply. It's actually quite lacking in a nerve supply, so it has to get its nutrients and that from this and get rid of its waste from the surrounding areas. And like bone, we'll learn more about the cartilage when we talk about joints later in the semester.